Hi friends, today we will talk about metric space and first of all let's recall the definition of metric space and its properties. Here are the three properties of a metric space. Metric space is a non-empty set X together with a mapping with these properties. dxy is equal to 0 if x and y coincide. dxy is equal to dyx for all xy from x because a distance between 2 points, in general, a distance is a non-empty, non-negative, sorry. Distance cannot be negative, it's positive. And third property is dxy is less than or equal to dxz plus dzy. If we want to show this, we should show all these three properties. If it doesn't satisfy this formula, we find out that the function doesn't define a metric on R. So let's find out that, let's take that x is equal to 1, y is equal to 3, and z is a point between 1 and 3. Z is 2. Let's show the first triangle property. Let's find out if this third property is satisfied or not. Okay, dxy is equal to d13, and if we use this formula, we will get that d1 minus 3 cubed, and it's equal to 2 cubed, 8. Let's find the result of dxz. This is equal to d12, and if we use this formula, we will get 1 minus 2 cubed, it is 1. And what about dzy? This is equal to d23, and this is equal to again 1. Let's plug these numbers here. dxy and dxy is 8. 8 is less than or equal 1 plus 1. As you can see, obviously from the given result, that this is not true. So the third property, the triangle property, is not satisfied. Therefore, this function doesn't define a metric on R. The second type of question is compute the distance d1 fg and d infinity fg when fg from the closed interval 0, 1 are the functions defined by fx is equal to x and gx is equal to x cubed. Let's compute. One has that x cubed is less than or equal x for all x between 0 and 1. Yes, x between 0 and 1, and this implies that d1 fg is equal to the integral 0 1 from 0 to 1 x minus x cubed dx. This is equal to the integral from 0 to 1 x minus x cubed dx, and this is equal 1 over 2 minus 1 over 4. It's equal to 1 over 4. This is in the distance d1. We plug x here, f, and we plugged x cubed here, and we use the d1 formula. What about the distance d infinity? D infinity fg. To compute the distance d infinity fg, we need to compute the maximum value of hx is equal to fx minus gx within the model, and x minus x cubed for all x between 0 and 1. Since let's plug h0 is equal to h1, if we plug here 0, it is equal to 0 minus 0. If we plug here 1, it's equal to 1 minus 1. Both the result is equal to 0. And h prime x is equal to, if we want to find the derivative of this formula, we will get 1 minus 3x squared. It easily follows that d infinity fg is the maximum hx. In order to find the maximum x value, we should solve this equation. 1 minus 3x squared is equal to 0, and here we get 3x squared is equal to 1. X is equal to the square root of 1 over 3. And let's plug this x value here, and h square root of 1 over 3 is equal to 1 over 3, the square root of 1 over 3 times 1 minus 1 over 3, and this is equal to 2 square root of 3 over 9. That's our result. Next question. Compute the distance d infinity x squared x plus 2. This is f and g in the space C02. We need to compute the maximum value of the function. hx is equal to f minus g, x squared minus x plus 2, and this is equal to x squared minus x minus 2 for all x between 0 and 2, because our interval is between 0 and 2. Since x squared minus x minus 2 is equal to x minus 2 times x plus 1, and this is less than or equal to 0 for each 0 less than or equal to x less than or equal to 2, then we have hx is equal to x squared minus x minus 2 is equal to x plus 2 minus x squared. And therefore, if we find the derivative of this formula, we will get h prime x is equal to, the derivative of x is equal to 1 minus 2 times x. Yes, and let's solve this equation. 1 minus 2x is equal to 0, x is equal to 1 over 2. This means that hx is increasing for x less than 1 over 2 and decreasing for x greater than 1 over 2. So d infinity x squared x plus 2 is equal to maximum hx x between 0 and 2, and this is equal to h 1 over 2. If we plug 1 over 2 here, we will get 9 over 4. This is the result. And next, final type of question is that show that the set A is closed in R. The set A is consists of all x from R, which satisfies this equation, this inequality. Sorry, and it suffices to show that the complement of A is open in R. Okay, so it suffices to show this complement of A is open in R, since x cubed plus 2x squared minus 3x is equal to x squared plus 2x minus 3, and this is equal to x plus 3, x minus 1. One has this inequality is greater than 0 if and only if, let's show, this is negative 3, this is, let it be 0, and let it be 1. And in this interval, this is greater than 0, and also in this interval, this is greater than 0. X cubed plus 2x squared minus 3x is greater than 0 if and only if x from negative 3, 0, and 1, positive infinity. Thus, the complement of A is the union of two open sets. So the complement of A is open and A is closed. Okay, that's all for today. If you have any question, please let me know. Bye bye.